Hey everyone, we're doing a worksheet on histograms. So let's jump on to question number 1. During 1 year, the midday temperature T degrees in Z4 were recorded. The table shows the result. Complete the histogram to show the information on this table. So the table is showing us the frequencies, and we need the frequency densities to plot here. So the formula for frequency density is frequency over class width. So for the first case, the frequency is 50 and the class width is from 0 to 10, so that is 10 minus 0, which is 10. So the frequency density is 5. So here we'll draw a length of a height of 5 from 0 to 10. Then the second case is done for us already. For the third case, the frequency is 100 over the class width is 15 minus 10, which is 5, which gives us 20. So we make a vertical line till 20 first, and then make a horizontal line from 15 to 20. I hope this is till 20. Yes, roughly. So this height should be 20. Next, for the fourth height, we have frequency 120 and class width 25 minus 20, which is 5, which gives us 24. So from 20 to 25, height should be 24. So just go 4 boxes, 8 boxes above 20. So here my lines won't be very exact. Alright, and then in the end we have frequency 10 over class width is 35 minus 25, which is 10. So height should be 1. So from 25 to 30, height should be 1. So 2 boxes above 0. So that's it. We have plotted our histogram. And why did we plot frequency density? Because of unequal class widths. Here it's 10, here it's 5, then 5, then 5, and then again 10. So when the class widths are unequal in size, we plot the frequency densities on the y-axis, not the frequencies. And the formula for frequency density is frequency over class width. Question number 2. The sizes of eggs are sold in a shop. 3 sizes of eggs are sold in a shop. The table shows the number of eggs of each size sold in 1 day. On the grid, draw a histogram to show this information. So again, we need frequency densities on the y-axis, and the formula for frequency density is frequency, which in first case is 78, over class width, which in first case is 52, minus 46, which is 6. So we get 13. So the first height should be 13 from 46 to 52. So where is 46? This is 40. 1, 2, 3, 4, 5, 6. So this is 46, and then till 52. This is 52. Now the height should be till 13. So take this till 13. Halfway between 12 and 14. So somewhere over here, and then join this. So the height is 13 and the width is from 46 to 52. Okay, then now the second frequency density will be found by dividing the frequency with the new class width. 62 minus 52, which is 10, so we get a height of 18. From 52 to 62, this is 62, and we need to go till 18. So here is 18. So you complete the bar like this, the histogram. Next is 162 is the frequency, and class width is 18. So 162 over 18 is 9. So from 162 to 80 we go till 9, and 9 is halfway between 8 and 10. So this is 8, roughly somewhere over here. We go all the way till 80. So this should be a little 2.5 boxes above 8 to get to 9. Okay, and finish this up, and you have your histogram. Okay. Question number 3. A factory recycles metal. The mass X tons of metal is measured each week. The table shows the result of 52 weeks. On the grid, draw a histogram to show the information in the table. So frequency density, again frequency density is frequency over class width. The first class width is 100, from 200 to 200, so 200 minus 100 is 100. So the first height, or the first frequency density, is 0.08. So that would be 4 boxes above 0, from 100 to 200. Like this. It should be a smooth horizontal line. And then from 200 till 250, 1, 2, 3, 4, 5, the frequency density is 20 over 50, which gives us 2 over 5, which gives 0.4. So height is 0.4. 0.4, yes. So height, go till 0.4, and make a rectangle. Okay. Next is 12 times 50, which gives us 0.24, I suppose. Yes, 0.24. So from 250 to 300, we have to draw a height of 0.24. This is 0.2, and then 2 boxes above that to get to 0.24. Alright, and then we have 12 by 200, which is 0.06. So from 300 to 500, the height is 0.06, which is 3 boxes above 0. So this is 0.06. Okay, question 4 is pretty much the same as the previous question, so I'm skipping that. Let's go to question number 5, which is the time t seconds taken for each 50 chefs to cook an omelette is recorded. Part B and C will probably skip because they're not related to histogram. Part C, a new frequency table is made from the results shown in the table opposite. Complete this histogram. So how many chefs have taken between 20 to 35 minutes? That's 6 plus 2 plus 7. So 6 plus 2 plus 7, and we get 15. Then how many chefs take between 35 to 40 minutes? It's still the same, 19, and 40 to 50 minutes is 16. Okay. So to check, you should always find the sum of all these, and it should equate to 50 chefs, which it does. Alright. And the next, on the grid, draw a histogram to show this information. So I'll quickly just show you the heights. The first frequency density is frequency over class width, which is 1. The second one will be frequency over class width, which is 19 over 5 is 3.8. And the third class frequency density is 16 over 10, which is 1.6. So we have to make bars of this height, 1 and 3.8 and 1.6. So from 20 to 35, height is 1. So the first bar. Similarly for the second bar, from 35 to 40, height is 3.8. So 2 boxes below 4, I believe. Yes, to get to 3.8. And then the last height is 1.6. So from 40 to 50 we go till 1.6, and that is 4 boxes below 2, roughly somewhere over here, and close this rectangle. Okay, so I've skipped question number 6 because it was just like the previous question 5. Okay, coming to question number 7. The table shows the amount of time, T minutes, 120 people each spend in a supermarket one Saturday. Part 2, complete this histogram to show this information. So the first frequency density will be frequency over class width, which is 20. The next one is already done for us from the first one is in fact done for us. This is already done. Then from 30 to 40 the frequency density is 18 over 10, which is 1.8. Then the next one is 22 over 5. Then the next one is 40 over class width is 5, which is 8. Then we have 21 over 10, which is 21 over 10 is 2.1, and this would be 4.4. Okay, so we have to plot these frequency densities. Okay, so this one is 30 to 40 and its frequency density is 1.8. so 30 to 40 frequency density is 1.8. so okay, so I've plotted all of the histogram. The 30 to 40's length was 1.8, so this is 1.8. Then the next length is 4.4, then 8, and then 2.1. Okay, so the next part says B. This histogram shows the amount of time, T minutes, 120 people each spent in the supermarket on Wednesday. So the first one was for Saturday. The next histogram, which is here, is for Wednesday. And the question said, make a comment about, let me read that again. The question says, make a comment comparing the distribution of the times for the 2 days. Okay, so I'm showing both the histograms side by side, so we need to make a comment on this. So notice there's a section over here in Wednesday which is missing here, and also there's a section over here which is missing here. So this is showing that on Saturday people generally spend more time shopping. So just make this comment, and let's see what it says in the marking scheme, which is on average shoppers spend less time shopping on Wednesday. So yes, this is an appropriate comment for part B. Okay, question number 8. The histogram shows the information about the time, T minutes, spent in a shop by each of 80 people. Complete the frequency table. So from the histogram, now we have to complete the table. Usually we were going the other way around. So the frequency density here is what? Read that. It is 1. I believe it's 1.2, because 2 boxes make 1 unit here, because 1.5 is somewhere over here, so this would be 1.2. So frequency density's formula is frequency over class width. So frequency density is 1.2 times the class width will be, class width is 0 to 5, so class width is 5, so 1.2 times 5 is 6. So the frequency for first part is 6, which is already given to us. Another way of finding frequency is simply by finding the area of this bar. So the area of this bar will be length into width, which will also be equals to this, which gives 6. So now I'll be using area method to find the frequency. So let's find area of the second bar, whose height is 1.2, 1.3, 1.4, 1.5. So its height is 1.5 times class width is 10. So the frequency is 15. Now the third bar is already given to us. Let's find the area of the fourth bar. This is height is, I believe, 1.2 and times 20. No, it's 1.1, not 1.2, which gives us for 22. So 22 is the frequency for the fourth bar. Okay, question. The previous questions were pretty much the same, so I've skipped a few. Question number 10. Deborah records the number of minutes late for trains arriving at a station. Okay, so Deborah records the number of minutes late for trains arriving at a station. The histogram shows this information. Find the number of trains that Deborah recorded. So we need the total number of frequencies. So we'll start finding areas of each bar and start adding them to get frequency for each bar and then sum them up. So okay, so the first frequency is simply the area is 12 and the class width is 0 to 2.5. Then the next one will be again the class width is 2.5 because we're going from 2.5 to 5, and the frequency density is 21, 22, 23, 24, 25, 26. Yes, 26 times 2.5. And then the third one is the class width is 5 and the height of frequency density is 10, 11, 12, 13, 14, 15. And fourth one is again the class width is 5 and the height is 10, or the frequency density. And for the last one, the class width is 10 and the frequency density is 2. So this becomes 20, 50, this becomes 75. 2.5 times 26 is 65, and then 12 times 2.5 is 30. Add these and hopefully we should get 240. 30 plus 65 plus 75 plus 50 plus 20, we get 240. Yes, so the sum is 240. Calculate the percentage of trains recorded that arrived more than 10 minutes late. So how many trains are arriving more than 10 minutes late? That would be represented by this region, this and this region. So a total of 50 plus 2, 70 trains arrive late, divided by total number of trains time 100. So 7 over 70 over 240 times 100, and we get 29.166666 rounded off to 29.2. Okay, question number 11. The histogram shows the length of time that 200 cars were parked. Calculate the number of cars that were parked for less than 100 minutes or less. So we're looking for the number of cars in this region. So we're looking for the frequency in this region, which is area of the bar. So the height of this bar, or the frequency density, is 3 boxes above 0.1, so 0.16 is the frequency density times 100, which is the class width. This is the class width, 0 to 100. So the answer will be 16 for part 1. Part 2, calculate the percentage of cars that were parked for more than 250 minutes. So now we need the percentage of these cars. So how many cars do we have in this region? This is 0.8 times 50 plus this is, what is this height? This is how many boxes above 0.2? Or 2 boxes below 0.3. So that would be 0.26 as well. 0.26 times the class width is 100. So this would give 0.8 times 50 plus 0.26 times 100, so I get 66. So now find the percentage. 66 over 200 times 100, which is 33. Question number 12. A survey asked 90 people how much money they gave to charity in 1 month. The diagram shows the result of the survey. Part A, complete the frequency table for the 6 columns in the histogram. Okay, so from 0 to 10, what will be the frequency? First we'll read the frequency density, which I believe is 1.3, and find the area under this graph. So 1.3 times 10 is 13. So we'll write 13 here. In fact, let's first fill up the upper row. The second row will be from 10 to, this will be from starting from 10 and ending at, this is 25. Yes, so 10 to 25, and then 25 to 30, like written over here. I'm just writing 25 to 30, and then 30 to 35, yes, and then 35 to 40, 35 to 50 in fact, and in the end 50 to 60, 50 to 60. You'll have to write it in this form: 50 less than x less than equal to 60, this way. Alright, so now next simply find areas of all the bars. So this one is 2.2 times 10 to 25, which is 15. So what is 2.2 times 15? It is 33, so we write 33 here. Then in the next bar we have 3.8 times, this is from 25 to 30 times 5. So 3.8 times 5 is 19. So we write 19 over here. The next one is already given, and you'll similarly find areas of these two bars and insert the values here. Question number 13. The histogram shows the distribution of the masses m of 360 apples. Use the histogram to complete the frequency. Now, the problem in this question is we don't have these heights. So we can't simply find the area of these bars and enter the values over here. That's not the case here. Instead, we're given this key. Now what is this? Let's comprehend this. We're told that this shaded area means 10 apples. So using this key, now we'll have to see how many of such shaded areas are present here, and we'll write the value here after multiplying it with 10 and so on. So how many boxes do we have here? 1 2 3 4 5 and 1 2 3 4 5. So 25 boxes are representing 10 apples. Keep that in mind. So boxes and apples, 25 boxes means 10 apple. So how many boxes do you have here? You'll be counting that in the first bar, And let's see that how many boxes do we have here. So that's 9 times 15 boxes, 9 boxes here, 15 boxes here. So 9 times 15 is 135 boxes. Then how many apples would I have here? So x will be cross multiply 135 into 10 over 25, which gives us 54. So the first bar is 50, the first frequency is 54, and you'll do the same with the second, third, fourth, fifth bar. Simply first count the number of small squares in this region and enter the value here and write x here. You'll do that, you'll get the values. It's 76 for the second frequency and 96 for the third frequency. Question 14, it's an important question. Okay, so the table shows the number of people in different age groups at the cinema. Dexter draws a histogram to show this information. The height of the bar he draws for the group 15 to 25 is 7. Calculate the height for each of the remaining bars. So whenever we're drawing a histogram, we draw frequency densities here. So frequency densities are plotted when the glass widths are of unequal size. So this is 10, then 5, then 20, and so on. So since the class widths are different in size, so we'll be plotting the frequency densities, not the frequency. So this height 7 centimeter will correspond to the first frequency density. So let's find the frequency density of the first bar, which will be frequency over class width, which is 3.5. So 3.5 frequency density means 7 centimeter. Then what is the second frequency density? That is 32 over 5. So what is 32 over 5? 6.4 will represent what height? Cross multiply. X is 7 times 6.4 over 3.5. So the next height is 12.8. So height for this bar would be 12.8. So the answer 1 is 12.8. Then again do the same for the next one. Now the next frequency density is 44 over 20, which is 2.2. So enter 2.2 here. So 3.5 frequency densities means 7 centimeters, then 2.2 frequency density would mean x centimeters. So to find x, 7 times 2.2 divided by 3.5, which gives us 4.4. So the second answer is 4.4. Similarly, let's find the third frequency density. The third one is 12 over 50, 60, 70, 80, 12 over 30, class width is 30. So 12 over 30 gives us 0.4. So when now entering the values here, 3.5 means 7 centimeters, then 0.4 would mean how many centimeters? So 7 times 0.4 divided by 3.5, that gives us 0.8. So the third height is 0.8. These are the answers for question 14. Question 15 is exactly like this, so you're going to do it on your own. In fact, all the questions, remaining questions are the same, so I'm going to do the last one only. Okay. Some students each record the mass of the school bags. Adil wants to draw a histogram to show this information. Complete the table below. Alright, so when class width is 6 to 7, in fact let's read the first row first because we have everything here. So when frequency is 32 and the class width is 4, the height is 1.6, but again the height corresponds to the frequency densities, not the frequency. So we'll find all the frequency densities. FD1 will be 32 over 4, which is 8. FD2, so this represents that 8, when frequency density is 8, then height in centimeters is 1.6. This is the baseline. Now FD2 will be it has to be found using this given ratio. So when the height is 2, what will be the frequency density? Let's cross multiply x times 1.6 equals 16. So x equals 16 over 1.6, which is 10. So frequency density is 10. FD2 is 10 from here, and since this is 10, now how do we find the frequency? We have the formula to find frequency. Frequency density equals frequency over class width. So to find frequency, we'll multiply the frequency density with this class width, which is 2, so we get 20. So this is 20. Now same for the third case. Again, we know that frequency density 8 means height is 1.6. So when the height is 1.2, what is the third frequency densities? So y will come out to be 8 times 1.2 divided by 1.6, which is 6. So frequency density is 6, so frequency will be 6 times the class width, which is 1. So the answer will simply be 1. Alright, we're done with this worksheet. I'll see you next time. Take care. Bye.